Hi everyone, I am Julka. Today's topic is inverse trigonometry. In part 1, we had already discussed some basic formula of inverse trigo. In part 2, we will discuss domain and range of the function and some more formula of inverse trigo. Domain and range of functions of given to us. We'll start with range of sine inverse and tan inverse. Range of sine inverse is minus pi by 2 to pi by 2 in closed interval. Range of tan inverse is minus pi by 2 to pi by 2 in open interval. And also remember the range of cos inverse and cot inverse. The range of cot inverse is 0 to pi in open interval and the range of cos inverse is 0 to pi in closed interval. We'll start with some basic questions. Evaluate sine cos inverse 1 by 2. Value is cos is 1 by 2 at pi by 3. Or we can write this way also. Sine cos inverse cos pi by 3. Which is equals to sine pi by 3. And the answer is root 3 by 2. Next example. Simplify sine inverse sine 3 pi by 5. But the answer is not 3 pi by 5. Because this 3 pi by 5 not lie between minus pi by 2 pi by 2. So we will write this way, sine inverse sine pi minus 2 pi by 5, which is equal to sine inverse sine 2 pi by 5. And now the answer is 2 pi by 5 because 2 pi by 5 belongs to minus pi by 2 to pi by 2. Next example. Tan inverse tan 7 pi by 6. But the answer is not 7 pi by 6. We will write this again. Tan inverse 10 pi plus pi by 6, which is equals to tan inverse 10 pi by 6. And the answer is pi by 6. And we know that pi by 6 belongs to minus pi by 2 to pi by 2. Next example. Cos inverse cos 7 pi by 6. But the answer is not 7 pi by 6 because it's not lies between 0 to pi. So we will rewrite this cos inverse cos pi plus pi by 6, which equals to cos inverse minus cos pi by 6. Cos inverse minus is pi minus cos inverse x. So this is pi minus cos inverse cos pi by 6, which is equals to pi minus pi by 6, and the answer is 5 pi by 6. Next example. Evaluate tan inverse tan 5 pi by 6 plus cos inverse cos 13 pi by 6. We will rewrite this tan inverse tan pi minus pi by 6 plus cos inverse cos 2 pi plus pi by 6. And this equals to tan inverse minus 10 pi by 6 plus cos inverse cos pi by 6. Tan inverse minus x is minus tan inverse x. So answer is minus tan inverse 10 pi by 6 plus pi by 6, which equals to minus pi by 6 plus pi by 6, which is equals to 0. Next example. Evaluate tan inverse 10 9 pi by 8 plus tan inverse 10 3 pi by 4. So we will again rewrite this tan inverse 10 pi plus pi by 8 plus tan inverse 10 pi minus pi by 4, which equals to tan inverse 10 pi by 8 plus tan inverse minus 10 pi by 4. And the answer is pi by 8 minus pi by 4, which equals to minus pi by 8. When we talk about right angle triangle, we know base perpendicular. Sine inverse P upon H equals to cos inverse B upon H equals to tan inverse P upon B equals to cosec inverse H upon P equal to sec inverse H upon B equals to cot inverse B upon P. Evaluate cos sine inverse minus 4 by 5. We know that sine inverse minus is minus sine inverse x. So it is cos minus sine inverse 4 by 5. Here perpendicular is 4, height is 5, so base is 3. minus theta is cos theta. And we can replace sin inverse 4 by 5 by cos inverse 3 by 5. And the answer is 3 by 5. Next example. Evaluate cos sin inverse minus 7 by 25. Sin inverse minus x is minus sin inverse x. So it is cot minus sin inverse 7 by 25. Perpendicular is 7 and hypotenuse is 25. So the base is 24. Cot minus x is minus cot x. So minus cot sin inverse 7 by 25, which is equals to minus cot inverse 24 by 7. And the answer is minus 24 by 7. One more formula. Cos inverse x plus cos inverse y equals to cos inverse xy minus the root of 1 minus x square and the root of 1 minus y square. We can straight away use this formula, or we can use alternative method. So we'll understand this by an example. Evaluate cos inverse 4 by 5 plus cos inverse 12 by 13. And we know the above formula, cos inverse x plus cos inverse y, which is equals to cos inverse x into y minus in the root of 1 minus x square into root 1 minus y square. Replace x by 4 by 5 and y by 12 by 13. And after solving, we'll get cos inverse 48 by 65 minus 3 by 5 multiplied by 5 by 13, which is equals to cos inverse 33 by 65. Or instead of this, we will use, or we will convert cos inverse into tan inverse. In the first case, base is 4, hypotenuse is 5. In the second case, base is 12, hypotenuse is 13. So perpendicular is 3 and 5 respectively. Or we can interchange like this: tan inverse 3 by 4 plus tan inverse 5 by 12. We know the formula of tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. And after solving, we will get tan inverse 56 by 33. Here, perpendicular is 56 and the base is 33 and the hypotenuse is 65. So we can say that tan inverse 56 by 33 equals to cos inverse 33 by 65, and we'll get the same answer. Simplify sin inverse 8 by 17 plus sin inverse 3 by 5. In the first, perpendicular is 8, hypotenuse is 17. In the second, perpendicular is 3 and the hypotenuse is 5. And the base is 15 and 4 respectively. We can convert this into tan inverse. Tan inverse 8 by 15 plus tan inverse 3 by 4. And now we'll use the formula of tan inverse x plus tan inverse y, which is equal to tan inverse x plus y divided by 1 minus x into y. And after solving, we will get tan inverse 77 by 36. If you see this carefully, the perpendicular is 77, the base is 36 and the hypotenuse is 85. Or we have one more formula: sin inverse x plus sin inverse y equals to sin inverse x in the root of 1 minus y square plus y into the root of 1 minus x square. Suppose the example is like this. Evaluate sin inverse 8 by 17 plus sin inverse 3 by 5. Now we'll use the above formula. Sin inverse x in the root of 1 minus y square plus y in the root of 1 minus x square, and replace x by 8 by 17 and the y by 3 by 5. And after solving, we will get sin inverse 8 by 17 into 4 by 5 plus 3 by 5 into 15 by 17, and will give you answer of sin inverse 77 upon 85. Or sin inverse 77 by 85 here, or we can convert this into sin inverse. Here perpendicular is 77 and the hypotenuse is 85. So we can say that tan inverse 77 by 36 equals to sin inverse 77 by 85.